Hello YouTube. In this video, we are looking at how we can do the control of reverse and forward motion of a motor using programmable logic controllers. We are going to do a simulation in TIA Portal version 17 of Siemens. To get started, let's look for our TIA Portal V17. Wait for it to load and ensure that you have a very fast computer or high power processing computer, because this is a heavy program. So right away, create a new program and we are going to call it motor reverse forward. So wait for it to create this project. Once you're done, click on configure the device and add a new device. So we are going to add a controller, basically a CPU of S71200. So let's pick one of this kind and make sure that your version is above 4. So 4.5 is good for us. So once our CPU is created, let's right away go and create our main ladder logic program. So we click on program blocks, we go to main, and then we are going to call this forward motor. So we are going to add the contacts here. Click on this, move, add a contact, reach here, come back to the rank, add a normally closed contact, add another normally closed contact, and we shall see their purpose. So add a coil for reverse. So come here and no, this is a forward coil. So come here and call it reverse a motor. So now we add a push button, we add a rung or a branch, add a push button, come here and close, add a normally closed contact, a normally closed contact, and let us add a coil. So these are tags and we are supposed to fill them with the names of the tags and the addresses. So to do that, let's go to PLC tags. So show all tags. So there is none, we shall just add or create new ones. So we are going to create a start, a forward start, This is going to be a forward stop, and we are going to put a reverse start. We put a reverse stop. Then we are going to put our forward coil. We are also going to put our reverse coil. So these coils are the ones that are going to energize the motor in the reverse and forward directions. So let's look at the addresses. This address here is okay, this is okay, but these ones are not okay. Since they are outputs, we are going to use the Q. Then this one is also an output. So okay, our tags are done. So what we do, we go back to the main program. So here we are going to put the forward start. Here we put the forward stop. Here we put the reverse coil for arching, because we want when we start the forward motion or the forward direction, the reverse coil or the reverse contactor must not be energized so that we avoid a short circuit. So that's why we bring a latching mechanism so that we store the address of the reverse coil here so that when a power is moving, once it is here and we have energized the forward direction, then this one is always in the low state. So it will always move, but then in the reverse direction, this motor is not going to be, the coil is not going to run. So let's go to the forward coil. Come here, we add a forward coil. Do a latching style. Then here, this is reverse start. This is, we are going to put our reverse coil. Then this is going to be our forward coil. This is going to be our reverse stop. And this is going to be our reverse coil. Our reverse coil. So once we are here, let's check the properties of our file or our program. We come here to protection, make sure this is not selected. Okay. Then we go to, okay, meanwhile, we can also compile before we go to the CPU. So, okay, we are done. Let's go to the CPU. Click on device configuration, go to the CPU, click on general properties, and come to security and make sure that this one is unselected. Then go ahead and give it for access. So once that one is done, let's get back to our program, ladder logic. So when we are here, we can start a simulation so that we compile and load the configurations of this program on the CPU. So consider as trusted. Okay, so you load. Make sure you load the configurations and wait patiently. So once that is done, come here and say start module and finish. So to check our simulation, you can come here and click on monitoring on and off. So obviously it shows you that our program is able to run successfully. So for simulation purposes, what we are going to do is to create a force table. So we go to watch and force tables, we create a force table. So in here, we are going to be looking at we are going to put the buttons that we are going to be pressing so that we run our simulation very well to mimic the real practice in the field. So now we are going to begin with, we have a forward stop, we have a reverse start, we have a reverse. This one can receive a 1 and So this is how we are going to do it. So once we press start, obviously this forward coil is going to be energized, whereas this reverse coil is not going to be energized because we don't want the two coils to be energized at the same time. So let's force the inputs. So you can see this forward coil is receiving power, and therefore the motor is running in forward direction. So we want to make it false. So we have stopped the forward motion by pressing stop, and now we are going to energize the reverse. So we want to move in the reverse direction. So reverse start, I want to give it a true. So when I give it a true by forcing the input, obviously the reverse coil here, you see it is de-energized, but this other side, I mean no power is reaching here, but this one is energized. Because of this latching mechanism, this is a normally closed contact. Once it is high, then it will never allow power to reach this side. So you can see once the reverse start is high, then we have the motor running in the reverse direction. So we can now force this one to stop. So we force it to stop. Okay, and make sure that also the forward stop. Okay, make sure that this is true. This is false, and this is true. So we force. Obviously, it is going to stop because we have said the reverse direction or the reverse button should be on stop. So this is how you can run your motor in reverse and forward direction, but this can be controlled using TIA Portal Siemens PLC program. Thank you, and see you in the next lecture.